one nice series, infinite series that if we can recognize that we've got it, we will know a lot about this series is the geometric series. And of course, the geometric series is tied into that geometric sequence. It's the very same thing, except instead of a sequence, you've got a series. And so, as before, all right, so 1/2 plus 1/4 plus 1/8 plus 1/16. Yeah, and so I've got this series, and I can recognize here, hey, the terms are geometric, aren't they? Because 1/2 and then times 1/2 times 1/2. So I've got a ratio here. So this is a geometric series with r equals 1/2. All right, now, what about this one? 2 plus 6 plus 18 plus 54 plus... Is that a geometric? Series?
Yeah.
R equals what?
3.
3, yeah. And if you don't see it, just start dividing the terms. 6 divided by 2, 18 divided by 6, and so forth. Yeah, that's R equals 3, yeah, geometric series. What about this one? 1 minus 2/3 plus 4/9 minus 8/27 plus 16 over 81. Minus, etc. Is that a geometric series? Yep. Yeah, we haven't talked about it yet, but series doesn't have to be just adding terms. You can have some subtraction in it. In this case, we're alternating between addition and subtraction. But yeah, this is a geometric series. R is what?
Negative 2/3.
Negative 2/3? Yeah. If it's alternating, it's going to be a negative R. R is going to have a negative sign in it. Yeah, negative 2/3 each time is what's been multiplied to the next term. I believe so, yeah. All right. Now, of course, we also have the summation symbol. Be able to recognize that geometric series in that. That's the 2 to the nth series sequence, but in a series format. So yeah, that's geometric. R is 2. Now you got to be a little careful. What about this one? That one's geometric. Well, it kind of goes back to what we were talking about. It's better to have it in, if you want a geometric series, you want it in the r to the nth power form, right? At least the ratio to the nth power. All right, so here, I don't quite have it, but just a small little slight adjustment here. Isn't this the same as, would this be the same thing? Yeah. 1/2 to the n is the same as 1 over 2n because the top still, I mean, obviously here the top is always going to be 1, and then you're going to have the power of 2. But that's going to be the same thing. 1 is going to be the top on all those. So that's the same thing. But that's more recognizable as a geometric because the r is 1/2. Right? So sometimes it's just making a slight adjustment there, and you can really tell. And then, of course, it doesn't have to be the end. This is yeah, that would be geometric, and the R would be 3. It's just that base there. Is that okay? Yeah, the base of that thing that's to the nth power. That's what's going to be your R, your ratio. Okay. All right. Now, turns out, yeah, geometric series are also very nice because, for one, we can tell when they converge or diverge. And second thing, too, also, even beyond that, is if they converge, there's a formula for what they converge to. And it's really the only series that we have where we have that particular formula that we can tell what the geometric series converges to. You can actually get a number for it. So it's pretty special, pretty nice series. Yeah, the geometric series, in general, here's what it looks like. A times R to the n, that's a geometric series. Ratio R. And the geometric series converges much like the geometric series converges, with one little exception. So geometric series converge if geometric series converges if, well, it all hinges on R, doesn't it? That R has to be same thing as, basically the same thing as the geometric sequence. A geometric series converges if R is between -1 and +1. With one little notable exception, and that is, notice what I left off there, the equal to 1. Because, yeah, the geometric sequence, 1 to the n, that converges, because it's just a sequence of ones, right?
Sure.
So they're staying at 1, so they converge to 1. However, if I try then to add them, that's not going to work out so good, right? Because that's just going to keep adding 1 to each time. Yeah, that's not going to converge. So notice that piece is left off. It's strictly between -1 and +1. Okay? All right. Now, so it converges with that. Let me do this then. Let's do this. Okay. Let me go ahead and give you. All right. So a geometric series converges if it's between 1 and -1, the ratio. If the geometric series converges also, then there is a formula. For the sum of this series here, for this series, and this is what I'm saying, this formula, this is the only one we have a formula for. The sum of the series, if you've got R between 1 and -1, turns out it's A divided by 1 minus R. And that can be a little bit misleading again if, this is hinging on well, actually, in this case, it would be this. For n equals 0. So this, this is, here's what you need to know about this formula, okay? So this is A divided by 1 minus R, or this A and that A. So to get this A and that A, because, to correspond, because to get this A and that A to match, what this A here should be is the first term. And you see why I did n equals 0 here, because if I did n equals 1, starting with, A would not be the first term. The first term would be A times R. A times R to the first. See what I'm saying? If R equals 0, A times R to the 0, R to the 0 is 1, so the first term is A. So anyway, make that a little adjustment, but it's first term divided by 1 minus the ratio. Okay? That'll get you the sum of the series. So in other words, if we go back to that 1/2 to the nth power, geometric, R equals 1/2. So what this series converges, and so what this converges to is A over 1 minus R. Well, what is that equal to? The A is the first term. So what's the first term here? Well, by my, I didn't write the index here, but by my rule of thumb here, we said we'll start with n equals 1 until further notice. So n equals 1 is the first, maybe I should put it there, just to be clear. All right, so at n equals 1 to infinity, the first term would be 1/2, right? In this case, first term is 1/2. The ratio is also 1/2. I mean, those two won't always be the same, but in this case they are. So this actually, it's 1, isn't it? 1/2 divided by 1/2 is 1. We'll do some more. Just a second. What about this one? Sum n equals 1 to infinity, 1 over 4 to the n minus 1. What does that equal? Because that's geometric, R equals a 4th. Right? So it's in the parameters here, it converges. So it converges to A over 1 minus R. Well, what is A here in this case? Well, if we plug in the first term here, we got 1/4 to the 1 minus 1, so that's 1/4 to the 0, so this first term is 1. So just have to figure out, based on your index, what that first term is. In this case, it is 1. And we've already said the R is 1/4, so it's 1 over 1 minus a 4, so that's 1 over 3/4. What's 1 divided by 3/4? 4/3, yeah. 1 divided by 3/4, 1 times 4/3. Yeah. So it's just whatever case may be. Now what if I've got it like this? Two plus 2/3 plus 2/9 plus 2/27. Okay. Can we find the sum here? Well, again, it hinges on the fact it's got to be a geometric and it's got to be R's between -1 and +1. Is that what we've got here? I think so, isn't it? It's geometric because I've got what? R is what? 1/3? Yeah, 1/3 times that, 1/3 times that, gives me that, 1/3 times that. Yeah, so that's geometric. R is a third. So what's the sum? Call it S. That S would be then A over 1 minus R. Now, the good thing is, in this particular case, I've already got the first term is already specified here. It's 2. And then the 1/3 is the R, so it's 2 over 2/3? What's that? 2 divided by 2/3? 2 times 3/2? Okay. One more like that. 2 minus 10/3 plus 50/9 minus 250 over 27. Is that one doable? No. What's the R? It's geometric, but R is negative 5/3? Yeah, negative 5/3. So that's not within the framework, is it? Within the parameters. So this one diverges, does not converge. So the sum is not possible. Yeah, ours, that's outside, that's bigger than, or less than -1, isn't it? Ours not between, less than -1. Something like that. All right. Try this one. -5 to the n plus 1 over 4 to the n minus 2. That one converted? Well, with what we know, all we know right now about convergence is if it's geometric and R is between 1 and -1. Well, to be geometric, it needs to be more like this, right? And that's not at all what we've got. So, yeah, some of these, they're going to want you to rearrange, make it look a little different. So here's what we can do. Let's break the top up like that. -5 to the n plus 1 can be written as -5 to the n and then -5 to the 1. Then the bottom, same deal. I can do 4 to the n times 4 to the -2. So that's just splitting apart the power, since we got a +1 and a -2 there, like that. So then I can combine these together because they're to the nth power, and so those two go together. And of course, these two are just whatever they are, they're just numbers. That would be part of the A. It'd be -5, and then this would flip up and be 4 squared on top, right? And then I'd have -5 over 4n, the n. So just recombine those under the nth power. And so there, pretty well spells it out, doesn't it? This is just a number, negative 80. -80? Is that right? Yeah, -80. But this again, that's again not in the convergent possibilities, is it? It's R is -5/4, which is not between -1 and +1. So it diverges. This one diverges too. Let me do one more of those and then talk about something else here. All right, so what about this one? 3 to the n plus 2 divided by 2 to the 4n. Is that convergent? Well, let's do the same thing on the top, 3 to the n times 3 to the second. I'll split that, break that up into the two little components there. But this is a little different. How am I going to write that? How would I write that? Because it's not 2 to the 4th times 2 to the n. That's not what that is it? That would be 4 plus n. 3 plus 4. Yeah, this is more using the power rule, I guess, if you will, for exponents. It's that, isn't it? It's 2 to the 4th to the n, which is 16 to the n. Yeah? Which now, we combine our nth power ones of the, let's write it as 9 times 3/16 to the n. Which, hey, yeah, that's convergent, isn't it? R is 3/16. So that converges. It's between -1 and positive. So what does it converge to? Well, it's a over 1 minus r. What's a here? Just the first term, yeah. Again, it doesn't say, it starts with 1. It's my little thumb here I'm using. So n equals 1, so it'd be, a would be 9 times 3/16 to the first, which is 27 over 16, right? So it'd be 27 over 16 over 1 minus r. The r is 3/16. So that'd be 27 over 16 divided by 13/16. Is how much? Sixteens are going to cancel, aren't they? So it's times 16 over 13. 27 over 13. Okay. Yeah, so that we hadn't really talked about, but that's kind of remarkable that this is going n equals 1 to infinity. I'm adding up infinitely many terms. And the infinitely many terms add up to be 27 over 13. Infinitely many terms. So it goes to a specific number. It's pretty remarkable that it does that, but it's just the way it goes. Okay? All right.